I'm here today to talk about some ongoing research that we've been doing for about 4 years. And we've been looking at the way in which we can use large volumes of social media data and try to figure out what implications there are. I should first say that this is a result of a lot of collaboration. There were 3 of us who worked on this particular paper. But you can see these are some of the people we used. Most of the people at the top are people from computer science, visualization specifically, and then a whole lot of research assistants within our program. The program that I teach in is a dual degree program in computer science and architecture. Master's degree, students come and get degrees in both. It's unique in the United States. I'm not sure about other places. So we were inspired partly by Carlo Rotti's early work. It's 10 years old now, where he showed the data from cell phones. We were jealous that he was able to get that data at all, which is impossible in the United States. And he showed what the data looked like spatially located during the World Cup when Italy won the World Cup, and it's very evocative. We were interested in the way, and this is a scene I'm sure repeated all over the world, all the students appearing to be praying, but actually just looking at their cell phones, and they spent all of their time on their cell phones. And we thought there must be some way in which mobile social media, or there potentially is some way in which social media is going to influence the way that cities are used, and we began to investigate the way that worked. I'm sure you're all familiar with the fact that this is Twitter, the growth of Twitter early on, and the exponential growth of it, and the amount of social media that came. It all contains temporal information. We know when it was sent. It has some spatial information, although that's very sparse, and it has semantic data that's completely unstructured, which is one of the things that's both attractive about it and that makes it very interesting to study. This is the kind of data that we get when we go out and find it, and it's long strings of texts, and it's everything from the ranting of our current president, right, which makes no sense, to all kinds of things that are just random and that aren't organized. There are 500 million tweets a day, and there's an open API, both of which are very attractive. This is the API. The first thing we did is we tried to use the open API to figure out what was happening. There are some problems with the open API, but it is nice that you can ask for tweets from particular areas. So we used that in the first iterations when we went about trying to do something with this. So one of the things we did is we were interested in, this happened to be in Chicago, and what we would do is we would have ask the API to give us all the tweets in Chicago and all of the ones that dealt with music, and so we were able to accumulate about 20,000 tweets, and we could find geolocations for most of those. Even though they're sparse, if we specified them, we were able to use them. And then we located where those were inside of the city. And in this case, we were then taking all the tweets that had to do with music, we were sending them through Wiki that categorized them. It's a standard way that they categorize them. And it was a way to be able to find some meaning in the data. And then we did that against the demographic information that we had for Chicago. Where were they? Were they in particular neighborhoods? Were they ethnically did the ethnographic information tell us where they were? Did different styles appear in different places? And some of it was fairly predictable. We found out that rap was more focused in areas that tended to be African American, but actually had a fairly wide diffusion across the city. And so it was a little bit of an early exploration about how we might do things. One of the things we found was that when we zoomed in, that the tweets tended to be concentrated on major streets and not out in the middle of the sort of housing blocks, which was an early indication that something was happening. The second thing we tried with the same approach was an airport study, where we went to the local, the Charlotte Douglas Airport, and we got all the geolocated tweets that we could for a period of about a week, and we got them all. And they appeared about where we thought they would. They were on the concourses. One of the interesting things we did with that data is we were able to identify a number of people and then look at their tweets over time. And so this diagram shows the tweets on the day they were in the airport. That's the red one. And then tweets 5 days before and 5 days later. So what it turned out to be was that people were tweeting more when they were in the airport. It was a kind of event, and lots of tweets happened there, and many fewer before and after. So we were trying to figure out what that might mean. Last thing we did with the same approach was Banksy. I was working with a student. He was a big fan of Banksy, and he was praying that Banksy would do something during the period he was looking at it. And it worked out. Banksy installed in Bristol on this day, and then he was able to use that hashtag and collect a whole series of tweets and geolocate where the tweets were coming from. So this is the tweets over time. And you'll see they begin to spread out more and more, and Bristol out into the immediate, and then this is London. So over time, it spread over about 4 days and became a very popular site. These are some of the data we collected about what the tweets looked like in that case. The second thing we did was we realized the limits of what that was. So one of the things we did was we got together with the Data Science Institute at our campus. And they had a wide open pipe well, not wide open, but they had a big pipe coming from Twitter. And so we could collect millions of tweets. And we collected 4 million tweets for Los Angeles and for New York. We figured there might be some significantly different patterns between these. And we were able to do them. They were all geolocated. And then we used Python scripting to be able to take the data and figure out what it might mean. And so this is just a straight geolocation for where all the tweets were in Los Angeles County. You can see that they're not evenly distributed. Los Angeles is a little odd because it's got a mountain range in the middle of it, but they're largely concentrated along the coast, and in West LA you can see a much higher concentration of them. We then looked at it relative to demographic data. Was the tweet density predicted by the kind of demographic information that we could get from the census? It turned out, as we looked at it, and these are all diagrams that begin to talk about population density and the tweet count to see if we could figure out if there was any pattern. There was only one that we found that really made any difference, that was statistically significant, and that was the points of interest, which we used some real estate information or use information about what was going on. And what we found out was that places that were public places seemed to have higher tweet counts than other places. This is not necessarily what we thought might happen. We also did some work with that same Twitter information that we had, and we began to look at how it related to TODs, or transit-oriented design, to subway stations in New York. And in Los Angeles, of course, there's a much newer system, and we were looking, how does the tweet distribution work relative to the distance from the station? And we found some interesting things in Los Angeles where the tweet count wasn't at all consistent with the stations. Then sometimes it varied significantly. And this is a diagram about the anomalies where the tweet counts were much higher going away from the station. It turned out those were mostly places that were, like Dodger Stadium had a very high tweet count, and it turned out that it wasn't evenly distributed across the city. The events significantly influenced this. We did one other thing, which was we developed a flow diagram. We did this by taking anybody who tweeted more than one time and then we mapped them using the same algorithm that's used for any mapping application. We didn't know that's exactly how they got from point to point, but we figured out in the aggregate that that would be a good approximation. And then we did this on the map of Los Angeles, and this gave us an idea over any time period how people who were using Twitter were moving through the city. We were also able to do something else which was interesting. In Los Angeles, it turns out there's a large body of Spanish language tweets. As you know, there's a large Hispanic population in Los Angeles. And so we were able to map the ways in which the Hispanic tweets or the Spanish language tweets and the English language tweets were different. And this is one diagram that began to get to that. And this is a map of the ways in which the flow through the city differed between the two different groups. We couldn't reach any particular conclusions in this, but it was an interesting thing to see the differences between the two groups. And this is another diagram about tweets versus language using some false color. So as we went forward with this, we realized that one of the most important things was we had to be able to do something with the unstructured data. And we used something, and this is a bit over my head statistically, but we used something called LDA. This is a topic modeling algorithm, and it's able to take huge corpuses of information and generate statistically significant incidences of groups of words. It has no idea what those words mean, but they present you, they say, these 10 words all appear significantly together. A human user can look at them and say, oh, they're talking about sports, or they're talking about going to the beach, or whatever it is. So the topics are not determined by the computer. The fact that they occur at the same time is, and then users can make inferences from that. So at that point, we realized that there were some real problems with the way that we were approaching it, because what was happening was we were having to do a whole lot of coding to get anything to come out. And we needed something that was going to be useful, that could be very fluid. So we worked with our colleagues in the Visualization Center on a visual analytic interface. And this is the overview of the visual analytic interface, conceptual overview. The machine is on one side, and it's doing all kind of data management, and it's doing some statistical analysis. And on the right-hand side is the human being. Human beings are incredibly good at certain things. Like, we can only remember 7 independent variables, but we can recognize patterns in beautiful and immediate clarity. Machines can remember infinite amounts of information, and they can't do much with pattern recognition. That's why CAPTCHAs work so well, right? Why can't a machine read these stupid things that a 3-year-old can? It's because we're really good at patterns. Computers are really good. And so there's a symbiosis between these two things. This is a general flow diagram of the way in which it works, and the way in which the body of geolocated tweets come in, and then they're processed, and then what we think is going to happen at the end of that. This is the interface that we designed as a result of this. We've published earlier versions of this, and it's available. It's probably not up right now. It's on our university servers, and they're doing things with them. But if you're interested, you can go to this website and actually play with it real time. This contains the 2 million tweets in Los Angeles, and you're able to actually navigate it. It's a visual analytic interface, and for those who don't know how this works, anytime you move one thing, all the other connected windows move at the same time. So to give you a few instances of how this works, when you move when you zoom in or out, it changes. In this case, we're just using a simple word cloud, and it's showing you the density of tweets over time. And so you can navigate and get closer to something. It'll change what the word cloud looks like. So it's really useful. It's quick. It takes almost no time because it's all pre-processed. This is another example. This is a full topic model interface. So this is what the interface looks, what the output of the algorithm looks like. And then you're able to say, just show me the ones that have to do with that topic. And you can go in and look at where they occur, what the frequency is, and you also see the word cloud at the same time. So you're able to select days, you're able to set shorter time frames, and you can navigate around this thing, and it's virtually instantaneous. You can also do this with you can select when you want to see the flow diagram of the city and what it looks like. It turns out that all of the sexy thing about the flow diagram looking like it's actually flowing is meaningless, because all it's doing is showing it over time, and that's not really relevant. The final diagram, though, shows you how some group of people or people who are doing a particular tweet might be moving through the city. And this one is a language selector where you can go in and pick the tweets that are Spanish language, English language, or in this case, there's some other cohorts, although they tend to be very small. So based on all of that work that we did in the transitions, what our ongoing interest in is in knowledge generation. When we, this interface that we use, we have done a user study at Roger Williams University, and this is the kind of thing we got out of it. It was a set of prescriptions and then information that came out, diagrams that came out. We think we need to structure that a lot better, and we're using an approach that's called the knowledge generation paradigm, which involves ways in which you have people use these interfaces and start with an exploration, go through a verification loop, and then into a knowledge generation loop. And it has to do with structuring their interaction with it in a way, and we're working on that in the ways in which we can structure that for people who are using this, because it becomes much more fruitful. The second thing we're doing is that we're doing ethnographic studies. When we realized that many of our things were telling us that tweets were not evenly distributed and they tended to be more in public spaces, we said we can't get very far with that using only Twitter data. It breaks down when you try to do that. So we are now using ethnographic studies. We're using ride along and follow up, where we actually go with people and watch what they do over time. We're actually doing interviews with people about when they tweet and if they tweet in public spaces or more distributed throughout. And then we've done these studies where we actually go into public places and look at where people are and what they're doing. We see this as a complement. And finally, we did some immersive studies where we went into public places and watched how people use it. So we went to rock concerts. It was a better rock concert video yesterday, but we went to rock concerts, saw how people were using this. And so finally, our approach to this is that, based on the call from this conference, is we were interested in how human beings and the way they find meaning can become both the subject of what we do, it's what we try to figure out from the unstructured thing, and the process by which they discover things is important to them, that we want them involved in what we do in a way that allows them to use their insights to complement that of the machine. So thank you very much.
Thank you, Eric. Any quick questions for Eric?
Thank you, Eric. Really good presentation. What's your experience? Are public authorities related to planning issues, are they interested in these tools, and do they actually, because it's really powerful tools for planning, what's your experience? Are they talking to you, or are you talking to them?
Some of you may know that Twitter has been used for things like emergency identification. There's some papers that show that Twitter can be faster at identifying emergencies than anything else. So if there's a fire breaks out in somewhere, it goes through Twitter before it goes through official channels. And so there's interest in that on the emergency management side. We've just arrived at the analytic interfaces, and we're going to be testing it with a number of groups, but we don't have any official sort of interest yet. I'm sure they'll come to us with millions of dollars of grant money. Yeah.